everybody. Welcome to the show, episode 130. Appreciate that, Rick, what you mentioned in that. I couldn't do it without you guys coming on every Tuesday, spending your evening listening to me ramble. So I really appreciate it. I hope you guys find useful information in what we're doing here. So I wanted to start off with, since we're at an even number on our episodes, 130, I wanted to go back over wiring again. Ryan says, evening, Professor, everyone. Hope you're warm. It's a little chilly down here, not terrible. I'm sure Rick has got a much colder amount of weather up there in Pennsylvania. But it was like 48 this morning, and I think it's 56 right now. Supposed to go to a golf tournament on Sunday, and I know Dave was just mentioning it's gonna be chilly. Hey, Wrenchins, how you doing? So I want to start off with a couple episodes on wiring. I want to start getting this where you can find them easier and stuff. Minus 12. Wow, dude, that's cold. Just like normal. I mean, if we would like to see anything above freezing, yeah. But if while I'm in doing this thing with the wiring or any other thing that we do on the podcast, just go ahead and put it in the comment or in the chat right away, and don't worry about interrupting or anything, because I really don't have a curriculum spelled out. I mean, this is I just get kind of shoot off the hip. So, hey, Chuck, how you doing? So we just kind of go back and forth and stuff. So don't worry about interruptions or anything like that. I want to make it, a two-way deal here. So, we'll go ahead and go over that. From last week, kind of catch up on the shop stuff. So last week we went to the Cool Wheels show. We talked about that and showed some videos on Scott's Skylark, which really isn't finished yet. It really hasn't. I haven't had any. If I have 20 miles on it, it's a lot. And usually, as I've said in the past, I like to get 100 miles on at least. And we have some things we're getting out, but Scott wanted to take it to the Cool Wheel show, and I thought I had it well enough to make that venture. That car had been about a 6 or 7 year project. It's been through a bunch of different shops before I started helping him. Actually, when I started helping him out on some of his cars, it was actually still in the body shop, but it had been to a multiple amount of shops before that. And we don't remember if I did it or if the shop previously did it, whatever. But the rear brake calipers, the mounts to the axle housing, were never tightened, I guess, because it came apart. So we had to fix that on Saturday. Got that all straightened out. And I had my buddy Jonathan come over and drive it. We thought we had a shudder coming from the transmission, and I think it's a dry shaft issue. That car's actually got a 2-piece dry shaft in it, because the tunnel in the car is very low, and it was a 2-piece from the factory. But when we lowered the car to get the stance we wanted, the dry shaft was in the floor, so we had to put a 2-piece back in it. But the second half of the shaft is really small in the back of the car, so there's some driveline out of alignment there, and that will be something when we'll get into some driveline stuff down the road. But then in the rest of the week I spent working on the T-type. So I've got the wiring harness for the fuel injection made up, and that's what made me think about getting back on wiring and stuff. So that's where we're at now in the shop. The harness is done and ready to go in the car, and move on to get that thing wrapped up. I got the engine back for the Smurf, Papa Smurf Jr. So Gabby and the guys at EIC have got the engine all dialed in, and I have to get the car in the shop to get the motor put back in. That'll be probably beginning of next week. There's some parts that I needed to get. They won't be here till later on anyway. So see how that goes this year. To catch you guys up, you may not have known about this Smurf. It's a grudge car that I do all the maintenance work on, and I do all the at-track maintenance. Small block Chevy, stock bore center, nitrous oxide injected, 84 Monte Carlo SS. So what the grudge racing evolved in is they kind of put monikers on different kind of cars. So the top shelf or top elite small block cars, they call them A-League cars. Typically billet blocks, cast heads, lockup converters a lot of times, and stuff like that. These cars are the ones that are really putting it to it, and then kind of turns into big dollar race cars. And then you got your B League and C and D League, and obviously the D League cars would be more of the guy does it out of his garage, no lockup converter, single stage nitrous, cast block, cast head, stuff like that. So typically we would just go to races and do straight grudge racing against another car, but the problem is the A-League cars got to the point where they got so much money invested in them nobody wants to run anybody singly, because if you beat this guy, then the next guy thinks he knows how fast you're going. So Ryan says, will you ever be able to give details on the Smurf engine, maybe last year's specs? It's a stock bore center, so 4.4 inches between the bores. So the block is a stock dimension block. So obviously you can't go any bigger bore than like a 185. And it's stroked, obviously. It's hard to give too much information away, because if a competitor happens to catch one of these shows, he'll figure out what we're doing. Yeah, I can definitely give you guys some stuff. So it's multiple stages of nitrous, turbo 400 with a lockup. Pretty fast car. It's an old school car compared to what's out there nowadays. Most people are building Corvettes now because they're carbon body. Back in the day, the rules used to be steel roof and quarters. Now the rules are no pro mod distorted shaped bodies. It has to be a stock dimensional body. But our car is steel roof and quarters. Used to be stock suspension in the front, but they don't do that anymore. The cylinder heads, to tell you the honest truth, they are something that EIC race engines developed, so it doesn't even have a name for the cylinder heads. It's something that they work on their own, and that's kind of at this level. That's what happens. You get a lot of this stuff is they get a casting and then they rework them. None of it is anything near what a stock engine would be. These heads, I can tell you have ports the size of big block Chevrolets, tunnel ram manifold and big throttle bodies and stuff like that. So kind of hard to say really how big it is or how, like the brand of the cylinder head, but because it's a brand that you wouldn't probably know, because it's casted one-off proprietary for EIC. So I guess it's an EIC cylinder head, I guess is what you would call it. But anyway, so everything's very very trick and very high end. And so what they started doing in the last couple of years, they started doing shootouts. So they would get 4 to 6, 8 cars to show up, and then they'd have a shootout format and race from there. But now somebody got smart and they actually created an A-League racing series. So I think there's 6 or 8 races that are going to be throughout the country, and you're going to get points along with the gambling. So we're signed up for that, and that should be good. I'll get some more information on that here in the future. Wrench says, I've seen crazy custom milled 4-bangers that use nitrous to spool up massive turbos. Pretty wild. Yes. And I can tell you that this thing is, a heavy amount of nitrous is going into this engine. So pretty much if you just think, if you could just dream of everything you'd want, a list of everything you'd want, how much nitrous you dream up how much you want to put in, all that kind of stuff, how big the cylinder heads could be, how big the valves could be, and you could just check off the list, and that's what basically this thing is. So unfortunately, like I said, with the grudge racing, it's hard to really give a lot of detail out. And there's probably a handful of companies that build these engines. EIC here in Lakeland, Florida, Gabby and his crew are one of the big grudge race engine builders here in the Southeast. You got TRE out in Texas, Rear Morrison, Bischoff. So it's at that level. I mean, you don't see too many cars coming out without a big engine builder in the background, because there's always development going on all the time. The engine is continually being modified to keep it going. So, but anyways, that's going to be getting together here pretty soon, and we'll go from there. So let me show you what I did with the T-type. Let me see. I thought I had that paperwork up in front of me. I do not. Let me get it here. And this is basically kind of what I want to. This is a little bit more advanced to where we're going to start out with, but I just wanted to show you what I did here for this car. Then we'll get into the actual wiring deal. Where are we here? All right, so for some reason my PDF isn't working anymore. I don't know what is going on with that. Okay. I got all my windows all overlapping. So, okay, so here we go. So, working on a wiring system, we're going to go over how I do it, but I'll show you what I did with the T-type. And the first thing I do is figure out where the ECU is going to mount, and then I use tubing to lay where the harness would naturally lay. So you can see on my little cheat sheet here, the ECU mount to the bulkhead in the firewall, I have 55 inches. And then all these numbers up here are coming from the bulkhead. So TPS, coolant, cam, crank, IAC, oil temp, oil pressure, map, all those things are, there's going to be a branch 15 inches from the bulkhead. So in other words, there's going to be a bulkhead connector. It's going to be a straight line coming out of there, 15 inches long, and then all those sensors that I just mentioned would branch off from there. The wideband comes straight out at the firewall, 25 inches. Injector harness, 3 inches. Coils at 4 inches, because it's right behind the distributor. The intake air temp is 9 inches. 32 inches for the flex fuel. Now, like I said, there's a branch for all the other sensors. And then from the branch, TPS 13, MAP 10, IX 6, coolant 5, oil temp 25, cam 4, crank 18, oil pressure 25. So that's how I figure all that out. And then let's see, I'm going to do this here. Let's see where. So I don't want to do that. So then I have some boards I set up on a table, and I lay everything out like this. So here's the ECU mounted here. I run screws in the board. Let's see if I can bring this up a little bit. So you can see I screws tight together, and that shows where the harness is laying. And then I break pieces off like this, where different sensors are going to be, and I go ahead and write what sensors we're going to lay down there. Here's the second half of the board. Whoa. So here's our branch down here, and then it's going to break off with all of our different sensors. And that's how I basically lay it out. So the other thing I do, which I kind of got ahead of myself, the first thing I would do is I get a pin out of the wiring harness. So let me open this up. Really messing with me. So on this, for the Holley system, I print this pin out, and this is all the pins that are in the ECU coming out. And then I start making notes. So the harness that I got, they do not make a harness for a Buick T-Type or for a 6-cylinder for that matter. So you got to kind of lay it out yourself. So what I do is I figure out my cam sensor, crank sensor, TPS. Those connectors are going to be different than like an LS. This harness started out as an LS harness. So I have to get all those information. So here I've got the ABCs. Those are actually the pin identifications on the connectors. And then next to it, you see the B20 and A14, A22. That is where the wire comes from at the header at the ECU. So what they give you some little information is whenever you have a connector that's got multiple wires, like at the ECU or anything like that, they usually call that a header panel. And so here's our J1A connector, and on your Holley stuff, A connectors are always your inputs, and then the B connectors are always your outputs. So there's our wire positions, and then a description of what that circuit can do. So that's what I do here is I just lay everything out so I know where I'm building myself a roadmap. You don't have to create a wiring harness design. Rick could probably do that since he used to do drafting, but it gets crazy to do it like that. So I just do it this way, and then as I'm building the harness, I can go and see where things are supposed to be. So let me go back here. Keep forgetting I can't open this natural. I gotta. All right. Excuse me. So on this thing, a couple weeks ago we worked on this. Hey Ron, how you doing? So yeah, this is a first seminar on wiring. I'm just going over what we did in the shop. So this is my coil mount that I built to run the IGN 1A smart coils. These things are super powerful. Cars are running up to 4,000 horsepower on these coils without a magneto or anything. So they won't be turned up that hot on this, but we created a bracket that mounts where the stock coil pack module assembly used to mount in the car. And you can see I put a vacuum manifold on the back, so or boost manifold, so all my lines to the wastegate and blow-off valves and all that stuff are all going to be hardline with push connects, so we won't have to worry about hoses blowing off and stuff like that. And it's real nice and neat, and it's coming right out of the manifold, making a loop right up to here and then off of that. So just trying to make it as clean as possible. And there's the assembly mounted on the engine. So the wires will be, kind of out of the way of everything, and it's just going to make it really clean. Just a couple different angles of everything going. So then I take my Holley harness and I disassemble it, because like I said, this was made for a LS and it's not going to fit this thing, and so got to strip her down. Yeah, they got big heat sinks on those coils because they have a module. Why they call them smart coil. Each coil has a module built in, and with the Holley system, we can run up to like 9 millisecond dwell angle on them, so they can put out a extreme amount of energy, and doing so, they build an extreme amount of heat. So they have heat sinks in them so they can cool. And of course, because it's coil unplugged, they're not firing like a regular single coil all the time. It's firing every 6 times. So you got time for heat dissipation. But anyway, so yeah, we strip it down and then start laying it out on the board. And then from there, you start breaking it out. Some stuff's got to be lengthened, some stuff has to be moved around and stuff like that. So you got to start doing it. That's why I like to break it all down and do it. These harnesses will fit in a car without modifying them, but they just don't make a lot of sense. As you can see, here's the fuel pump coil injector relay that energizes all that stuff. It's way down line. Well, in this car, this is going to be in the passenger kick panel where the stock ECU mounted. So I want the relays right here by the kick panel, because that's where, just to make it easy. Hey, Cole, how you doing? Yeah, no problem. We're just getting started on the wiring stuff. So, and then of course with those big coils, I have to break things down. This relay now will only run injectors, power up the flex fuel sensor, and I powered up one other. I powered up something else with it, and then the coils are. And the fuel pump, a trigger wire to another relay in the back of the car for the fuel pump, and then there's a second relay for the coils, because those coils need 40 amp service just for the coils themselves. So you can see here the harnesses were kind of nowhere where I needed. Like here's your IX off the board and stuff. So just it would fit in a car, but it'd be wiring be all over the place. And when we're done, this is going to look like it was obviously custom made for the car. So here you can see now I've got my coils moved up here next to the ECU. I got a fuse for the injector and accessory, and the second fuse for the coils. And the nice thing, the way Holley does it is all these relays will only turn on when there's a crank signal. So you can leave the ignition on and program the car and do everything you want to do, and you don't have to worry about coil saturation or the fuel pumps being the fuel injectors being triggered or anything like that. So it just makes it nice and clean. And then as soon as there's RPM signal, the relays engage and everything turns on, and it works great that way. So there's now I have all my connectors terminated where they need to be with the lengths in line. You can see, there's all the different ones. I kind of put some screws in there to kind of to get a length, so it keeps everybody separated from the other stuff, so it's easier to put the harness back together. So these the doubles are inside the car, and the last pair of doubles here is where the bulkhead connector is. So that's going to be the injector harness and the 2 coil harnesses, and then the battery wires going to the coils because they are taking that big service. And they do make harness. There are people that do make harnesses for Grand Nationals and T-types, but the problem is this thing's got the IGN coils in it. It's got a boost controller in it. It's got oil and trans fluid temperatures going in a harness. All those kind of things would not be in a standard Holley harness. Plus, it's got the flex fuel also. So even if you buy a harness pre-made, I still end up taking it apart to make it fit the actual installation that I'm doing at the time. That way, this is all one installation, nice and clean. I do all the wiring and all the additions or any changes are all in the colors, color coded to the Holley harness. I have tons of wiring that already has stripes on it with white stripes and black and yellow and red and stuff. So I can match the exact wires that the Holley harness would come with. That way, the next person can pull the sheathing off at a sensor and see the colors and look at the schematic and know exactly what it was for. So just the kind of thing you want to do when you're making it easy. Now, obviously, if you're doing a single installation, it's kind of hard to do that, although there are companies that you can buy 10 feet of wire with the stripes on it. So, you can do it. So anyway, here's all the F6 wire looms back on. So, wrench sense, that's what my pinout sheet, I give that to the customer. So that's got that, and plus the factory Holley wiring schematic. Everything on here is already color coded to that schematic, so I don't have to double do it, so to speak. The owner would get that stuff, and plus you can always, if you lose it, you can download it right off the internet. So, but yeah, it makes it real simple to do, and then with the F6 harness, it looks pretty nice. You can get crazy with heat shrinking and doing all that stuff on a street strip application. I like to do it with the F6 because you can always go in and repair wiring if you get splices and stuff like that. If you get a wire caught, down the road you get a wire caught between the trans and the bell housing and the engine block or something, you can easily fix it. Where if it was all heat shrinked, now you're cutting heat shrink and basically making the harness have to start all over again. So, but yeah, that's the harness all set up and everything. So, just want to show you that. That was kind of just to give you an idea of where we're at in the shop for at this point. So let me close that out. So let's kind of get started here in the wiring stuff. So last week I kind of showed you guys some of the stuff. We talked about TXL wiring and GXL and the different grades of wiring. You can go back and look at that again if you see fit. But what I like to do is whenever I'm doing a wiring job, and I'm going to use painless because a lot of people use the painless systems. I keep forgetting I can't open it without. There we go. So what I like to do is let me go switch this over. So you get your painless harness kit or whatever wiring harness kit you get. They'll give you a fuse box typically, and they'll give you some connectors and stuff like that. And then what they'll do is they'll show you subsections. So let me like here's an alternator wire, and they'll show you that 914 is the white circuit, which would be your ignition check-in battery light on the dash. So that light bulb resistance is a turn on for the regulator. And then your 915 is your heavy power wire going to your recharge the car. And they'll give you sections like this where you have the painless wiring circuit number and the color, the color of the wires and the turn signal connector pins. So basically, I like to do that all the same kind of thing. And if we go back to let me go back to what I do with Dave's car. Sorry about that. I thought I must have cleared it. So I showed you guys this. This was a long time ago when I was wiring up Dave's Chevelle, and this is something I do, and I call this kind of like the pre-planning. Where is it? Sorry, should have had this stuff cleaned up here a little better. So, what I would do is, because you're always going to end up having to add more stuff to your wiring harness than your painless kit is, or if you buy a replacement kit, or you're fixing the factory harness in the car, you're going to be adding extra stuff, stereo, maybe power window kits and stuff like that. So what I like to do when I'm getting ready to wire up a car is I get notebook paper and I start writing down this stuff that I'm going to do. See if I can find. Well, there's all the instruction books, and that's an important thing. Let me go back up off of this. So when you're going to start a wiring project, and this is how you make it not complicated to do. I know a lot of people are really freaked out about doing wiring, and trust me, even me doing wiring for 40 years, when somebody brings me a car and it's been modified, it takes a lot of research and diagnostics to figure out what they did, because they've added stuff in there. You don't know where it's going. You got to trace it all out. People, they put, somebody, especially alarm companies, they're great about taping up all their work in the separate little tiny harnesses, and then they shove it all up under the dash. And then when you got an alarm system that's now defunct because it's old, and you got lights and buzzers going off and stuff, and you want to just cut it all out, it takes a lot of extra time. And I think that's why a lot of people get freaked out about doing wiring, is because that is a major pain when you got to do that. So what at that point, you have to dismantle everything. And what I try to do is I try to go on the internet and try to find the components that's there, and then go to the manufacturers and see if I can pull out wiring schematics. So that way, at least I've got colored identifications and can kind of backtrack what's going on. But if you're building a car, I know Rick's 55, he's going to be in a spot where it's just easier just to gut the car, especially the older 50s cars and older, because the wiring harnesses a lot of it was cloth. They had glass fuses, and just, all that age, car, 70, 80 years old, the wiring isn't going to be in very good shape anyway. So you're just going to drive yourself crazy. So the thing to do is to buy a wiring harness kit, and if you don't mind spending the premium money, the painless systems are really good. And then there's a lot of different systems below that are great also, but you have to do a little bit more of your own design and layout. In other words, they don't have it completely filled out properly. Whereas the painless has everything divided up into subsections. Yes, they do have the writing on the wiring, but they also have a circuit number, so it's very easy to follow along their manual. Where Ron, I'm not knocking anybody, but like Ron Francis or Hot Rod Wiring or any of these other companies, they'll have a circuit name on it. It'll say, lights or turn signal or whatever, but there's no instructions per se to go along with it. They may have a generic picture of turn signal switches and stuff like that, but it's not going to give you the main thing. So with that being said, what I want to do is, before I do a wiring job, is I want all of the components that we're going to install in the car. So as you see here, when we did Dave's, we had digital tail lights, vintage air conditioning. We got the Holley fuel injection. We got Dakota digital dash. We've got door locks, remote control for the locks, and you could operate power windows. I don't have it in this picture here, but it's got a backup camera on the rear view mirror, and so forth and so on. So all these components are there. So you got to get all those components, go through the instructions, and start writing notes. So what I do is I write down, or I highlight each of these components. Like I'll take a yellow highlighter, and I'll highlight all the grounds. I'll take an orange one and highlight all the power wires of all the different kits. Excuse me. And then I start making a list. And that's what's here. So, see if I got separate. Nope, I don't have it separated. So I make these lists up, and you'll end up doing these multiple times because you add another component. But it makes it real easy when you start making a list of where all your powers are going to go, where all your grounds are going to go, and you kind of start laying it out ahead of time. So that really helps make it non-scary on how it's being laid out, because now you've got a roadmap. You know where all the components are going to be, how they're going to be tied together, and then you can go from there. So now you're right. Wrench sends nightmare on the 60s Cadillacs. I think there's 8 relays to make the top go down, because the trunk's got to release, then the trunk's got to go up, and then the top's got to release, and then it's got to fold down, and then the top has to the trunk lid has to reclose and relock. It's crazy. So on something like that, you definitely want to get a schematic, and we're going to go over that in the next couple shows. Schematics and how to read the schematics and what the different components do and all that stuff. So we're going to break it down. This is just kind of like an overview of how we want to get started with this. So once I have my cheat sheets, I call it, all handwritten, and I've made modifications, I've had to rewrite them and stuff. When I'm all done, then I go and I do a spreadsheet. So this is kind of what I end up with. So here we've got all the wiring. So we've got the left front corner of the car. We have our circuits that are in the painless system with the colors and where they go. Center by the trunk, because we're going to have 8. We have a receiver dryer in front of the AC condenser, so that's in the center of the grill. So you can see we have the horns. The horns are mounted on a Chevelle, and on the bracket, on the core support, the bracket that holds the hood latch. So that's going to be in the center. We're going to have the binary switch and the AC engage on the binary switch on the dryer. That's going to be right there. With the Holley wants to see an input for the AC, so it knows to turn the fans on. And then the fans are going to be on the other side of the core support, but in the center. So we have our trigger wires for our fans. Then we got our right front. Then we have firewall. We got our wipers. That's the only thing that's going to be on the firewall, because we're going to make the firewall clean. Then we have the starter is going to be in this area. And then everything else is going to be behind the dash. So we have our dimmer switch, under dash wiring for our Holley, our vintage air. And then we continue on under the dash. We have our Dakota digital components. You can see here's A28 from the Holley system. All these other ones are from the circuits are from the painless system. Those are all of our battery, ignition, power up, our high beam, right and left turn, fuel sender, our radio, our door jamb switches, driver's door, our turn signals, passenger door. So you kind of get an idea of what I'm doing here. So with this roadmap, when the car is all done, you can take this map and go to these components and pull up the wiring and know exactly what's going on. It's not a wiring schematic like you would get from the factory, but it's broken down so you can diagnose or you can check things or where they go and stuff. And of course, then we've got the trunk. We got left side lighting, right side lighting, and then the center of the trunk. So that's what I like to, kind of how I like to do that. And that way you've got a roadmap when you get started. Then you can either build the harness in the car or do like I did before, is get some sawhorses and a plank of a couple sheets of plywood, and then start, mount your relay box, your fuse box in this section where it's going to be, and then you can from there tape measure out and run all your wires to different screws, and you can build the whole harness on the bench, and then go to the car and put it in. That's all your aftermarket harnesses that are pre-made, or even your OEM harnesses. That's how they make them. They've got these great big peg boards that are on a rotisserie, so it's standing up vertically, and they can move the pins around, and they build an entire bridge just like I did for the fuel injection. They'll make them trunk lines, and then they'll make them branch off and do all those things. So when you do that, I believe it makes it a lot less complicated. You do your measuring. Like I said, I use a piece of 3/8 silicon clear hose. It's very, very soft and flexible. And that way I can route it the way I want the wiring harness to lay. And then I just measure it out from bulkhead to where like the bridge is or separation. And then you can just go to your board and lay it out the same exact way. And then you can start running your wires and use zip ties or bread ties or however you want to do it to mount everything. And that way it's real easy as you go, as you keep adding things to it. So if there's, you need to move something or you put the wire in the wrong place, it's easy to move it, put it over there. And once you have everything all laid out, then you can start terminating and getting it all figured out. So the good thing is doing it that way is you've got some testing. So you can lay it all out. You can take your hose and go back over on the board and get your length, and then go back to the car and verify that the length is working, or do you need to add or subtract the wiring. It's always good to leave a couple inches extra, so that way you've got some wiggle room there. A lot of times I'll make it a little bit tighter than that because I'm trying to hide wiring and stuff like that. But that's a really good way of starting. So that's kind of what I'm getting at here is proper layout and design, and getting all this stuff done on paper before you even pull a wire out of the box makes it so much easier. You can just take your instruction books and like I said, highlight the components you're going to need, and then start writing down what's going to be under the dash, and you make it dash right, dash left, left of steering column, right of steering column, center, right of glove box. And then you can start laying out how everything's going to be, so that once you start going to the wiring, you already got a roadmap of what you're doing. So it's not having clumps of wire all over the place, and I don't know where this wire goes, I don't know where it's coming from, stuff like that. So it's so much easier to do the due diligence ahead of time and get it on paper, at least on paper. And then if you even go one step farther, lay it out on a board, and that way you can get it all set up. It is very time consuming, but it's something that if you take the time, it's not that crazy of a job to do. It makes it a lot easier, and it makes it a lot easier to understand what's going on. Aaron says, admit it, you put a young guy up under the dash. I still get under the dash myself, but I will say I used to just jump in the car with the seats in and everything else, and lay on my back and get contorted and everything else. Nowadays, I work a little bit smarter instead of harder, and I pull most of the interior out, put moving blankets on the floor, and make it comfortable to lay down. When I'm working under the dash, a lot of times I'll pull the brake pedal and stuff out, because that way you can get all the way up under the dash. A lot of cars will have a instrument cluster assembly, so you can usually pull the whole cluster assembly out of the way, and that's really helpful if you do it that way, because then you can make a pigtail on your cluster, so you can make your whole cluster pre-wired. Let me see. I should have some pictures here. All right. So now that we have, let me. That didn't work out. There we go. So yeah. So here's and of course, the Dakota Digital makes it a lot easier, but here's the cluster out of Dave Chevelle. So that whole assembly, the radio, over here, your AC controls go out here. That's obviously AC vent, but you got your lighter, turn signals and wipers, all that stuff all in there. So you can build all that on the bench and then have pigtails out. Now, the Dakota Digital uses these cat cables to go to the control box, but you still have on this particular one, you've got a power wire for your clock, and you've got power wires for your external turn signals. So you can kind of lay it all out. That's the stereo stuff. Let me see if I can find the one that's got the I guess I didn't get a good one of the Dakota Digital, but anyway, so that's it. Just proper preparation just makes it a lot easier. Wrench says not much too old, 100-year-old cars I work on, thankfully. Yeah, not much 100-year-old cars you work on. Yeah, it just depends on what you're doing. I mean, we work on a lot of older stuff. Obviously, your 60s and 70s cars, you can typically don't have to completely rewire a car. But when I'm building a car like Dave Chevelle, where it's all been updated with all modern technology, the factory harness just isn't going to handle what we're set up for. We talked about this last week with proper wire sizes. So on a 60s, 70s, 80s, even into the 90s, like a GM car, they only use a 10 gauge wire for the alternator because the alternator was only a 70 amp alternator. So it did great in the day. But now you upgrade the car to fuel injection, air conditioning, power windows, locks, stereo system with amplifiers, and all these electric fans, possibly electric water pumps, electric trans cooler fans, electric fuel pumps, all these components. You end up needing a lot more amperage to run everything, and the wiring harness in the vehicle is now not well enough equipped for that build. So that's why typically on a complete build like this, I usually gut the car and start off fresh with brand new wiring. Now we can put a 150 amp alternator. We can run a 6 gauge wire from the alternator to the power stud on the starter with a 125 amp or 150 amp maxi fuse in line. So all those things are now designed for how the car is built now. So with all that there, now you don't have to worry about having to go back and fix things down the road because everything was designed properly for what you're trying to get accomplished. So again, proper preparation is key. So that was the EFI. So yeah, so we talked about earlier, but this is how when I do the fuel injection. If I'm just doing just a fuel injection harness like I just did for the T-type, I just used a pinout sheet from the Holley instructions. And then anything that I have to modify from the factory harness, because the Holley harness is going to have all Delphi 150 Metropack connectors on it. And like the Grand National or T-type has the old square WeatherPack connectors for the IAC, for the crank, TPS. So those all have to be repinned to the proper connectors. So I just write it all on the sheet itself, so that way it makes sense, because those components are not going to match the Holley wiring schematic. So this way you've got the pin location at the connector, the pin location at the ECU header, and then you can, from the Holley wiring schematic, you can get the color codes, and then you can go back through all that stuff. So that's just to reiterate about that. Let me. So we want to get to. Let me see here. I wanted to show you something else here. I know it kind of bounced around because this is the beginning of the series, but again, if you're going to work on factory schematics, and you've got an older car, a 60s or 50s car or older, you can this is a place that I get schematics from. ClassicWiring.com. And the nice thing is they take the factory wiring harness assemblies, and they because the factory harnesses were all black and white, and they were very hard to follow. Let me see if I can bring you up one of those so you can see what I'm talking about. It's a pretty crappy picture, but let me I'll show it to you anyway. So here would be what an original schematic would look like. I think I got a better picture of it. Let me see if I can pull that up real quick. Sorry about that. I should have had this prepared better. Yeah, when you blow them up, they get kind of nasty. But here's a 69 Camaro wiring schematic, and obviously it's a little blurry. I apologize about that, but you can get these off the internet, and they're very hard to follow because you got to go down the lines, and they crisscross each other, and it's really complicated. When they go through these bulkhead connectors, they don't really have any letter identifications, so they're very complicated, and I can understand why people don't want to mess with them, because they are pretty crappy. For technicians that work on cars all the time, you kind of get used to it, because you have to. Here's another one. This is actually a photo of one out of a harness, and you can see they kind of have a wire size and the colors, but the colors are all abbreviations, and there'll be tons of P's for pink and B's for black, and you got to pull your hair out trying to figure out, well, which pink is it, which black is it. They didn't use a lot of striped colors back then, so a lot of the harnesses are all the same colors for different components. So very very frustrating and hard, and that's why I think why people are so scared of wiring, because this is what we used to have to work with, and it could get crazy. But now you can get you can get assemblies from Classic Car, and they'll do stuff like this where they've got some pin identifications. The wires are in color now, so when they crisscross, you don't have to figure out, is that wire turning or is it going, and it just makes it a lot simpler to check this out. So this is like on a Camaro with gauges and a console. So you got your cluster gauges and gear shift lighting. So on the older GM cars, that was always a gray wire. Your temp was green. So all this stuff color coded makes it way easier to figure out what's going on. So the Classic Wiring is a good company to get. I get a lot of harness schematics from them because it's easier to follow. Here's one from them that I copied, and you can see this is it's going to be a lot easier to deal with because it's all color coordinated. Now they may not give you the positioning, but here's your reverse switch. That's the shape it looks at, so you can know that left wire is going to be the pink wire and the right wire is going to be the light green wire, and it makes it very easy to trace it out. Blue for your oil setting, green for your temp. So it definitely makes it a lot easier to work on the car and follow the schematics. These are your junction blocks. This would be the back of the fuse box. This is in the engine bay. And again, they've got the shape and they've got the color code. So a lot easier to figure that out. Unfortunately, those units didn't have a letter or number identification from the factory, so they aren't able to put them on there because they weren't there to start with. But just a lot easier to work with the stuff. So if you're going to repair a factory harness and it's on and you can't get a color wiring chart, check out the Classic. The Classic guys, they're not that expensive. I think they're like $19, and they are plastic coated, so you don't have to worry about the paper getting nasty with dirty hands and stuff like that. Works out real nice. Oh, I hate when I do that. So that's what the sheet would look like. This is a '69 Camaro. And there is classiccarwiring.com. And they can usually get it to you in 2 days. So typically if I got a customer bringing me a car, Scott's Skylark is one of them. Actually, most of Scott's cars. It's a stock car with stock wiring. So I will order the chart from Classic Car Wiring and have it. Even if I'm not going to do wiring at this point, I still order it. And that way, when I do need to do some wiring, I already have the chart. I can follow it. It's easy to figure out when something's not working. You got an instrument not working or something like that. You pull the engine out, you put the engine back in, you got some wires, you don't know where they went. Well, you can get the colors and you can figure out where they go. So just makes life a lot easier, and hopefully makes the wiring a car a lot less scary. So let's see, what else do we want to touch on tonight? What I want to do in the next couple series here is I want to what I was going to do is we'll go into components and connectors and tools and stuff. So anything you want to get some more information on, put it in the chat, and that way I can bring it up. But yeah, so next week we'll probably go over components, and that way, when you're laying out your schematic, and you see a relay or a switch or something like that, we'll go over how that stuff is, how it works, and how it's wired, so that you can identify something and then know how to put it into your cheat sheet as you're building your directory for putting the harness together. That understanding what the components do is really important. That way, it just makes everything that much more easier. So we'll go over, instrument lighting, dash lighting, instrument lighting, interior dome lighting. That can be confusing to people. That's a power all the time that gets grounded to operate. Another one that it sometimes can get people screwed up is fuel sending units, because that's on a rheostat, and your temperature gauges and stuff like that. All of those things are usually thermistors. And what a thermistor is, it's a resistant that as it temperature changes, the resistance changes, and there's a scale, and your gauge and your sending unit, they have to match. Something I ran into a couple times with my buddy Scott, because he likes to take like his Le Mans is a 63, and 63 and 64 was a split. 63 had a 0 to 30 sending unit. The 64 and up, all the way to current, GM uses 0 to 90. So, when you switch the gauges in the dash, you got to know which gauge you're using so you have the right sending unit. But what he did was, the instruments in the Le Mans, 63 Le Mans, are the same size and shape as the 64, 65 GTO. The Le Mans only had a speedometer and idiot lights and a fuel gauge. That's all it came with. They didn't have any options. It wasn't a GTO or anything at that point. So on his car, we put GTO gauges in. We put a tachometer. We got the speedometer. We have oil pressure, water temperature, and fuel level. So we retrofitted all those other gauges into the pod, and then we had to change the sensors so that they would read properly. So that's something you have to put all those things when you're doing this kind of stuff. And I guess that's the main gist of what I wanted to get over tonight, is when you're getting ready to do a wiring job, put everything on paper, how it works, or at least get the schematic, and that way you can identify what is supposed to be happening and go from there. I see Chris is on. Hey, Chris, how you doing? And Chris, hope you don't mind me going over what we talked about the other night. He had an issue with his starter. Every now and then the starter would click. Scott actually had the same problem with his Corvette. And you would think, the starter's bad because it's clicking, but it's not engaging. That isn't necessarily true. So what you have to do is take a voltmeter and go to on a GM car, purple wire, which is the solenoid activation wire for the starter. That's the wire that's going to enter when you push a button or you turn the key to start. A purple wire typically will go through a park neutral switch or a clutch switch and then end up going to the starter. So first thing you want to do is read the voltage at the starter with it engaged, with the starter assembled, because that way it's going to put a draw on it. And if the wire voltage drops below 10 volts, the solenoid's not going to make the engagement, and it's not going to turn the contactor on. Starter's not going to work. So it's not a bad starter. It could be wiring drop. So at that point, then you have to take your voltmeter and start following where's that purple wire go from the starter. It goes to a neutral safety switch. So you check it at the neutral safety switch and energize the starter, see if you had a voltage drop. And it does, okay, then go to the next side and just work your way back to the ignition switch. And that you'll eventually find where it has good voltage and no voltage, or low voltage, and then that will tell you where your problem is. Wrench Sense says, purple wire, steel me junction. Yeah, that's a big issue on 60s cars. That's where the issue is with Scott's car. On the Corvette, 64 Corvette, it's just a plug, two pieces of plastic that connect, that push the connections through the firewall into the engine bay harness. And those contactors can get corrosion, crap like that. And next thing you know, you got voltage drops, and now the starter's not engaging, and it's not a bad starter. It's a wiring issue. So the diagnostics of wiring can be a little bit troublesome, but when you do that, you can find you know what the components are, and you have a schematic. They make it a lot easier to identify your issue. Ryan says, we've dumped everything unnecessary in my son's Capri, EGR, etc. I'm so confused. May just get a new harness for it. Yeah, so again, that's a prime example. So you're taking the car that had all kinds of crazy emissions stuff on it that you're not going to use. We're not going to have air pumps and all that kind of stuff. So there's two ways of doing it. One would get a factory schematic, and then you can see where all the wires go, and you can unterminate them from the end piece and pull all the wiring out, and makes everything a lot cleaner. Or go ahead and just put a new harness in it, and just that way you don't have to worry about that stuff. Wrench says, look for purple wires if you want to steal those cars. That's right. You can. Whenever I work on a GM car, I have a little screw wire piercer that's made for checking wires. But I use that. I can pierce it under the hood and put my bump starter on there if I want to, bump the engine over for valve adjustments and stuff like that. So yeah, that purple wire is the big, heavy 10 gauge purple wire. You know that goes to the starter on a GM car. That's what we're going to do next week. We're going to go ahead and we'll go over components, and we'll work a little bit more on diagnostics. That's Chris had to do some troubleshooting on his, and it can be so easy as just a wire pulled out of loose out of a connector, and can cause a voltage drop, and then now you've got a component that doesn't work. So it's just one of those things, and Chris unfortunately has had some people in his car wiring, and he's got to push the start button, which didn't come in a early late 60s, early 70s Nova. So like I told him, I said, first thing we have to do is get a schematic of the start button you have, so we know where the power is being triggered, where it's coming from, so that way it helps in diagnosing everything. But so that's, we're kind of going on long here, so we'll go ahead and pick up part 2 next week, and we'll think about what we talked about tonight. If you got questions, put them in the comments. That way I know to add them into next week's show. And if not, just go ahead and put it in the comments next week. But we'll go over components and a little bit more on how to do diagnostics. And then from there, we'll start going into what's needed to build a new harness or repair harnesses and stuff like that. So hope you guys find this interesting and you learn something. And when you get into a position where you got some wiring to do, it doesn't scare you to where you have to take it somewhere and pay somebody to do it. Because the problem there is if paying somebody else to do it is fine, but if you aren't getting any feedback as far as schematics and stuff like that, you're no better off than you were before. You still don't know where the wiring goes and where components could be failing and stuff. So the good thing about when you have you do your diagrams and stuff like I showed you, if you were on the road and you have a problem, you can pull that book out and be able to go over it. That's something that I do when I'm doing a car like this. As my buddy Scott says, they're Frankensteins, because we're taking all this different components and hodgepodge them all together. So one of the things I do is I get a big Ziploc bag, and all of the instruction booklets for all the components that I put in the car, I put in that plastic bag, and then put that somewhere in the trunk or in a pouch behind the seat or something where it can stay in the car. And that way, if you're ever on the highway and you have a failure, even if you're not going to fix it, if you're going to take it to a shop to fix it, you can give them the paperwork and say, here's how, it gives them a roadmap. It may not tell them exactly what they need to do, but it'll surely save them a lot of time, which then would save you money because they're going to charge you by the hour. So if you can help them process the wiring in the car faster, obviously they're going to spend less time and you're going to get a smaller bill. And the other side of that is, if you are going to fix it yourself, or you're on a power tour or a drive and drag or something like that, there's always a lot of people that'll pull over and help you with it. So if you have schematics or at least some type of drawings and paperwork of what you originally did, it helps everybody figure out what's going on and where the components are, and just makes everybody's life a lot easier and gets you fixed and back on the road at a much faster pace. So I think that's where we're gonna pull the plug here tonight. Remember to smash the like button, subscribe if you haven't subscribed, share videos with friends. We need to get more people on the channel, and we'll keep this thing going. So with that, I think we're gonna go ahead and call it a night. I hope you guys enjoyed it, and we'll see everybody next Tuesday. See ya.